All right, next piece we're going to talk about is scalability, cluster expansion. All right, from here, let's jump back into the demo. All right, and this is, we'll start with the OpenShift cluster. All right, so here we are in the Apex Cloud Platform menu. We're on the Inventory tab, so we're going to hit Actions and Add Worker Node. Right, what it's doing now is it's going through and searching for any new nodes. Any nodes that it finds, it's going to run a compatibility check against those nodes. Right, we want to make sure that those nodes are compatible with the existing cluster, because we're not going to allow you to add a node that isn't what we would consider compatible. Right? So once it's said, all right, this is a good node, we can select it, start to fill in the information. We have a couple modes here. We can do autocomplete, or you can select advanced, where you specify the values individually. Right? There is information that we've already pulled in from the existing cluster. So for example, the network information, the subnet mask, VLAN ID, all that's been pulled in already. So we're defining the name of the new node. We're going to give the IP address of the new node. And we're going to set the TPM passphrase for that node. All right, here we're going to set the location information, the rack name and rack position. And we're going to go into the NIC settings. So this is going to define those bonds. They're already pre-configured, matching what the cluster had already set up. Then we're going to go into the network settings and define the IP addresses for those. Right. From there, we're going to go into validation. And notice the VLANs are already pre-populated to match the existing nodes. Right, it's going to check and make sure everything's good with that configuration. And then from here, we can kick off the add node process. All right. And there is a little message, a little banner that's going to pop up here that says adding node into the cluster. Right, and from here, it's going through the process of deploying everything to that node, adding it into the OpenShift cluster, configuring the Cloud Platform Foundation software appropriately. Now we'll jump into the last one for the ACP for Azure solution. I'm going to skip ahead here because there's some other considerations related to ACP for Azure depending on what network model you're using, whether you're using the scalable, switchless, or two-node back-to-back configuration. Right? But the same type of process, what we're going to do is add the node. It's going to go through and do that same discovery of new nodes. So our current cluster size is 2 servers. It's going to find that there's a new node that's available, and it's going to run that compatibility check. Right? So it already says, all right, this node's compatible. Right, now we're going to go through the settings for that server. Very similar process, right? The IP address, in this case it's Windows, so we're setting an administrator password, the rack position information. The network's already pre-populated. This is going to match what the cluster is already configured for. And it's going to go through the validation and then the add server process. Okay. While this is running through, any questions? So really what we've done here with this product family is something that hasn't been done before in terms of bringing that infrastructure management directly into the CloudOS experience. And we're enabling that for different cloud operating models to give customers the choice as to which one or which ones they choose to run in their environment. I've left everybody speechless.
Good job.
So one of the things you kind of left out for the group here is that the Apex cloud platform for Red Hat OpenShift is installed on bare metal.
Yes, both of these are bare metal
If
solutions.
any of you guys have done anything with OpenShift on bare metal, it's a bear.
It's a bare metal.
Bare metal. Thank
Boom,
you.
boom.
Very good.
Grr.
It's a bear. It's a real bear, and that they have streamlined this to put it on bare metal. We had worked on in our lab doing it, and it was, I know I sound like I'm promoting these guys, but we've got a lab, and we did trying to install Red Hat OpenShift on bare metal, and we gave up even with support from Red Hat. They said, oh, we don't do it that way. We always put on VMs.
Yes, the vast majority of OpenShift deployments on-prem
Yeah.
are on top of a hypervisor today.
Yes.
And there's a couple reasons for that. Number one, you have the simplicity of deployment. It's much easier. The other piece is there is very little hardware integration inside of OpenShift.
Mm-hmm.
So lifecycle management of the hardware has to be separate from lifecycle management of the OpenShift software. Right? There's no mechanism to do the two together until now, right? So being able to create that separation between the two means you could update the hardware underneath without affecting the VMs running on top of it. So that you've decoupled, right? But by doing this solution, we've automated all of that for you, and we've put in place that entire lifecycle management of both OpenShift and the hardware together so that you don't have to do that. And the benefit is OpenShift on bare metal runs faster, right? You don't have a hypervisor in between, right? You don't have CPU scheduling and all of the other pieces. You don't have the licensing requirements for a hypervisor, right? You don't have the attack surface of a hypervisor. You don't have another layer of administration in the way between OpenShift and the infrastructure, right? So it vastly simplifies that process, gives you access as a developer to more of that hardware that OpenShift is running on, right? But it simplifies the process of using that significantly. And it opens up scenarios like what was being discussed with hosted control plane, where you could now better leverage that hardware to host additional control planes and even host through OpenShift virtualization virtual machines directly into OpenShift, right? A lot of people go, well, why would I use OpenShift virtualization instead of a hypervisor? Well, one of the aspects is with OpenShift virtualization, it's using KubeVirt. It's upstream KubeVirt, right? So I'm running KVM in pods. So I'm running that virtual machine inside of a pod. That means the workload on that VM can take advantage of pod-to-pod networking, right? If I was doing a VM outside of OpenShift, if I'm communicating with any workloads running on OpenShift, I'm going through that ingress. All that traffic has to be routed through the ingress controller. If I'm initiating that traffic from another pod on OpenShift, I get pod-to-pod networking. I'm not being routed through that ingress controller. I don't have to create an external route to expose that service outside of the cluster so the VM outside the cluster can consume it. Right? So there's a lot of benefits to being able to run those workloads directly inside of OpenShift.